Imagine a world where drylands, often struggling with scarce water resources, can thrive with sustainable agricultural practices. This is the ambitious vision of a groundbreaking study, led by Professor Wang Shudong and his team. Their innovative approach, published in Water Research, introduces an AI-powered solution to map the potential for forage cultivation in northern China's drylands, specifically targeting the middle reaches of the Yellow River. But here's where it gets controversial. The study challenges traditional single-metric assessments by proposing a spatial optimization framework. This framework simultaneously considers water consumption, soil carbon benefits, and forage production, offering a holistic view that many might argue is a game-changer for ecological protection and national food security. The team's cross-scale, multi-source fusion framework integrates satellite data, ecohydrological models, and field measurements, reducing the need for extensive on-site sampling. By applying advanced learning techniques, they achieved remarkable retrieval accuracy for key production factors, exceeding 90%. This accuracy, combined with distribution alignment methods, led to the identification of optimal forage belts with an impressive positional accuracy of over 85%. And this is the part most people miss: the framework's ability to quantify ecological gains, economic returns, and water costs on a unified scale. It's like having a precise map that highlights the most efficient planting areas and input-output ratios, guiding the allocation of resources and labor with unparalleled precision. The researchers emphasize the approach's replicability and cost-effectiveness, making it an attractive solution for regions facing strict water constraints. So, is this the future of sustainable agriculture in drylands? What are your thoughts on this innovative use of AI in remote sensing? Feel free to share your insights and opinions in the comments below.